And the winner, of course. From the table, the GCHE outperformed all the others fairly consistently. It met all the design targets. It seemed to me inherently simple, and hence that would mean an easy operation, repair, maintenance. It fits the landscape and spirit of the Bendigo Downs property, which I thought was important. The Cooma traditional owners are obviously very spiritually connected people. So it's integrated with the land, as well as being a sustainable solution. With their current shift towards solar power and self-sustainability, I thought this system seemed to be quite in line with what they were trying to achieve with the rest of the development. Next slide. This is the design itself. It's a very simple design. A water pump will pump water from the local water hole or bore into a manifold of piping in the walls and roof of the house. As it circulates, pardon me, as it circulates through that manifold, obviously heat energy is absorbed by the piping going through, and the water is heated up as it goes through the walls or roof. 15 to 25% of your heat energy is lost through your walls and 25 to 35% is lost through your roof. So I think these were the two main target areas that this system would be good for. It can also be adapted to just having a fan run over the top of it to provide a cooling solution, similar to an evaporative air conditioner. As I said, the water runs into the house, whether through the roof or walls, or as the evaporative air conditioner showed, and back out through the other side. And once it's heated, it would run through into a ground loop system. A ground loop is basically just a few hundred metres worth of polyethylene pipe, buried about 3 metres underground. About 3 metres underground is where the Earth's temperature starts to peak off, that it starts to smooth out on a graph. And obviously it's because of that, it averages out at about 18 to 20 degrees, which is quite a comfortable level. By the end of the ground loop, the water should have cooled back down to the surrounding Earth's temperature, about 18 to 20 degrees, and it would be pumped via the water pump back into the manifold. The water hole or bore or whatever outside water source would be used, even a tank, would obviously be just used for filling the system, as obviously the ground loop wouldn't have much effect if it was cooling water on the way back out to the bore. You just get a very cold bore. The system design also allows for a photovoltaic cell to be placed on the roof, not only to reflect sun's rays away from the roof, but also to run the pump itself. During winter, the piping at 18 to 20 degrees may not be as effective due to the temperature difference being lower. In the Bendigo Downs property, the winter maximums tend to average about 19 to 20 degrees, and so obviously this piping is not going to be absorbing as much heat energy. The artesian bores in this region are approximately 40 degrees though, and so by using the water there and tapping off that ground loop for the moment, we're able to run bore water straight through the system at about 40 degrees, and then once it's gone through the system, it would be sent off to a reservoir or to a similar ground loop immersed in hot water. That hot water would obviously be made by the photovoltaic cell, having incorporated a solar hot water heater. Because it's already 40 degrees, it wouldn't take very much energy to keep it at 40 degrees, and so obviously that solar energy would probably cope with that quite well. Next slide. As we can see from the table previous, time has been eliminated from the metrics, as I believe it was not much of a factor for this system as it would be for the others. So the design targets were met thus. For cost, Obviously the design is very cheap and easy to install. It just requires polyethylene tubing. I've chosen polyethylene to eliminate the possibility of cracks or bursting. Being a flexible pipe, it's obviously very good at coping with expansion and contraction of water as it heats and cools. The passive insulation was also forecast as an option rather than an integral factor due to the cost, and the system will work slightly less efficiently without it, as the insulation acts as a heat sink. This is when putting it into the wall cavity. Obviously putting it in with existing insulation is going to provide a slightly more efficient cooling action than would just putting it into a blank wall cavity. For simplicity, the design just had no equal other than passive insulation itself. Tubes, pump and some basic plumbing were all that was required. Operation is a simple tap handle, and the expansion is easy as joining another wall or ground loop into the system. It's certainly the most efficient system we looked at. Running costs versus the running costs versus the actual cooling produced by that system was streets ahead. Next slide. I just had a few remarks on the research I had to bring up. I assumed the air conditioning was obviously going to be installed by professionals. This is going to include material delivery costs, accommodation of the hired labour while they're doing the job, and this seemed a poor option for the community itself. The heat pump, due to its requirement of air circulation, was recommended to be placed in its own separate room, preferably subterranean. This would require a lot of modification to the current existing buildings, and the Coombe traditional owners had obviously specified they wanted a redevelopment rather than a complete rebuild. Both the passive insulation and the GCHE required wall modification, as did the air conditioning for ducting and so, but obviously to a much lesser extent. And so the GCHE just seemed a better solution overall, because it actually actively cools the wall space rather than just passively. And when it's used in conjunction with the passive insulation, it's obviously got much better standards again. Also, in relation to the passive house standards I mentioned earlier, the building would obviously be redesigned, taking into account current sustainable low impact design metrics and ideas to best utilise any of the systems shown above. That's all. I'd like to thank you for your patience and respect during my talk, and that's all.